Kia ora koutou. Here's a question from Andrew Booth looking at how to find the intersection line in two planes. So Andrew had a specific question that I'm going to do, and this is all really well done in exercise 10F. Now I've got to say it's one of the most boring exercises on vectors that you can find, but it's good practice. So let's look at what the skill involves. We're going to find the vector of the equation of the line of intersection of just this pair of planes here. Alright, so we'll just delete all those ones. And the answer that we're going to end up with is this. So the vector of the equation of a line, as you know, always has two bits. It has a direction vector and it has an initial point. And in this case, the initial point is this. And Andrew emailed me and said he couldn't see where this came from. And I think, Andrew, it was this bit here. So I'm going to go through this quite slowly in case there's anyone else watching who hasn't revised this yet. So let's think about what we mean by the intersection of two planes. So here's my first plane, right? And then we're going to draw, badly, another plane through it. And you can see in there that there's a line, right? A line of intersection where the points on the line have to be on both of those planes, or in both of those planes. So we've got two equations for the planes, right? We've got 3x plus 2y minus 6z is equal to 4, and we've got x plus 5y minus 7z is equal to 2. To find the direction vector, we're going to need to find 2 points, another colour pen, 2 points on that line. And from those 2 points, we're going to get the direction vector. So the difference in those will give me that. And one of those points we're going to use as the point in the equation of the line. But we've got more information that we need. We've got 2 equations and 3 unknowns. So we've got the luxury of saying, let's see if we make x equals 0, what values of y and z will fit as well, and that will usually work. Now sometimes, as I've said in class, there's an easy combination to do and sometimes there's a hard one, but I usually just, if there isn't one that's obvious, I usually start by letting x equal 0. So here we're going to have 2y minus 6z equals 4 and 5y minus 7z equals 2. I'm going to match up the coefficients on the y, and I'll get 10y minus 30z is equal to 20. Here I'll get 10y minus 14z is equal to 4, right? So that's timesing the first one by 5 and timesing the second one by 2. Now I'm going to subtract the second from the first, and I'll get negative 16z is equal to 16, giving me z equals 1. I take z equals 1 and I stick it back into any one of those equations. So 10y minus 30 equals 20. That gives me not what I want. What have I done? Z is equal to negative 1, not 1. That's better. 10y plus 30 equals 20. So 10y is negative 10, and y is equal to negative 1. Now I want you to notice how incredibly easy it is to go wrong with the algebra when you're in a hurry. You just saw me do it where I missed a negative sign. So a really good thing to do is do what I did and just take a look and see if it's fitting in, and check back with what you've done. The same thing goes for scholarship calculus questions, as I've said in class. Right, so we've got our point. We've got our first point here. The point is 0, negative 1, negative 1. Now I've got to pick another one. So I'm going to pick letting y equals 0, and I'm going to solve this. Now I want you to keep watching this, because the direction vector that I get looks really ugly, but I'm going to times it by a scalar multiple to make it a bit nicer. So here, that's what I'm left with the equations. So there's no y in here now. I'm just going to multiply the second one by 3. So we get 3x minus 6z equals 4, 3x minus 21z is equal to 6. And again, just check that you've actually times this one by 3 before we go on. I'll subtract one from the other. So minus 6z plus 21 gives me 15z, and here I get negative 2. And this is one of those times when you might be thinking you've done something wrong, because usually we know that in A-level problems the answers are nice round numbers, but there's just no way that usually will work out in these questions about the line of intersection. So here we've got a really ugly answer. We've got z is equal to negative 2/15. we now have to substitute this back in here to find x. So we have 3x plus 12/15 is equal to 4. 3x is equal to 3 1/5, right, because this is 4/5. So 3x is equal to 16 over 5, giving me x is equal to 16 over 15. Yuck. So the point here is equal to 16 over 15, 0, and negative 2/15. Now I can just about hear some of you saying, oh miss, you did it a stupid way. If you'd picked z equals 0, then blah blah blah. So that might be the case, right? But you're not going to know that if you get this in a problem under time pressure. So I say pick, if it's really obvious, pick that one, but otherwise just get on with it and check as you go. So what have I got now? Well, I've got the 2 points, right? The points are, let's see, well we had 0, negative 1, and negative 1, and now we've got 16/15, 0, and negative 2/15. Now those are the 2 points that I have to use to get my direction vector. So the direction vector is going to be this: 16/15, 0, negative 2/15, minus 0, negative 1, negative 1, giving me 16/15, yes, I'm using a diagonal line, so 1, and then negative 2/15 plus 1 gives me the horrible 13/15. So this is the direction vector that we're going to use as our base, but we know that that direction vector, the purpose of it is just to show the direction of the line. So if I'm going this many units out and up, then I can multiply everything through by 15. And that means that I can take the direction vector to be 16, 1, and 13. No, 16, 15, and 13. So the equation of the line is going to be 0, negative 1, and negative 1, my first point, plus lambda times 16, 15, 13. Right, so it's not a unique equation of that line. There are other points that I could have used here, and there are any other scalar multiple of that direction vector would have worked as well. All right, I think that's worth going over slowly if you are still watching this video. So 10F has got a few other wee examples that you might like to try. And as I said, the algebra is just really, really fiddly, but it's conceptually pretty straightforward. Please email me about that one if you've still got questions. Thanks.